Let us look at question number 51 now. Two rigid balloons A and B containing 0.2 mole and 0.1 mole of helium at room temperature and at 2 atmosphere respectively are connected by a stopcock. When the stopcock is opened and equilibrium is established, the final pressure of HE in the system is. So students, the number of moles are different, but it is said that the pressure as well as the temperature is same in both the cases. So it must mean that the volume of the balloon A should be 2 times the volume of balloon B. And it is further mentioned to us that they are connected by a stopcock. And when the stopcock is opened, as the pressure inside both the vessels are the same, there will be no increase or decrease in the pressure when the stopcock is opened. So the final pressure of HE will also be 2 atmosphere as it was initially present, as there will be no net change occurring in the system. So we have to mark option 4 as the correct answer to our question. Let us look at question number 52. Consider the following statements about the reduction of metals during their extraction and select the incorrect one. So in the first option it says that the reduction of metal sulfide is more difficult than the reduction of metal oxide. This is correct, students. The reduction of sulfides is difficult. If you look at the second option now, aluminium cannot be obtained by chemical reduction due to its strong affinity for oxygen. This is correct, students. Hence it is allowed to undergo electrolytic reduction. If you look at the third statement now, during electrometallurgy of Al, graphite is used as anode to avoid reoxidation of Al. This is also correct, students. The oxygen liberated combines with the graphite anode to form CO or CO2. Hence, the reoxidation of aluminium is avoided. If you look at the fourth option now, the reduction reaction is sluggish when the metal is formed in the liquid state at the temperature of reduction as opposed to when it is formed in the solid state. So this is incorrect, students. The reaction is sluggish when the metal is formed in the solid state. So the statement which is given to us says the other way around, and hence it has to be incorrect. So students, for this question we have to select the incorrect statements and we have to select the fourth option as the correct answer to our question. Let us look at the next question. Question number 53. So we have been given 4 different processes and the value of delta G naughts have been given to us. So the examiner seems to be interested in that reaction which has the largest value of the equilibrium constant at the same temperature. So students, we know that the value of delta G naught can be equated to minus RT ln K equilibrium. So greater the negative value of delta G naught, greater will be the K equilibrium value. So out of the given species, we can see that the most negative value of delta G naught is given in the third reaction, and as a result, the third reaction is going to have the maximum value of the equilibrium constant at this temperature. So students, for this question, we have to select the third option as the correct answer. Let us look at the next question now. Question number 54. At 783 Kelvin in the reaction H2 plus I2 giving us 2Hi, the molar concentration of H2, I2 and Hi at some instant of time are 0.1, 0.2 and 0.4 respectively. If the equilibrium constant is 46 at the same temperature, then as the reaction proceeds. So the examiner seems to be interested in the Le Chatelier's principle. So the K value is given to us, it is equal to 46. And if we talk about the Q value will be given by 0.4 whole square upon 0.1 into 0.2. So we have the value of Q equal to 8. And students, we can clearly see that the value of Q is less than Kc. So the reaction must shift in the forward direction. So as the reaction shifts in the forward direction, the amount of Hi shall increase in the system. So if we look at the options, we can clearly see that we have to select the first option as the correct answer to question number 54. Let us look at the next question now. Question number 55. When treated with concentrated HCl, MnO2 yields a gas X which further reacts with calcium hydroxide to generate a compound Y. The solid Y reacts with dilute HCl to produce the same gas X. The solid Y is. So when HCl is allowed to react with MnO2, we have the liberation of Cl2, which is the gas X. Now when this gas X is allowed to react with calcium hydroxide, then it forms bleaching powder, CaOCl2. And when this CaOCl2 reacts with HCl, it further forms Cl2, CaCl2 and H2. The reactions are not balanced in this case. This is the overall reaction sequence which is mentioned to us in the question. And if you look at the compound Y which has been asked to us by the examiner in the question, we can clearly see that we have to select the third option as the correct answer to question number 55.